So, Intellectus Statistics, statistics software for the non-statistician. Intellectus was a response to SPSS. Folks didn't know, how to, what tests to run. They didn't know how to navigate the tool and they didn't know how to interpret the output. And as you'll see, 10 minutes down the road, that the arc of those questions are answered with Intellectus in a very kind of seamless fashion. And we'll get to that. So the agenda for the day is basically to understand the basics. What is an independent dependent variable? We'll also talk about levels of measurement. Now, all I need is one hand to say that, yes, we need to go over the basics, and I'm going to go over the basics. Or if you need a refresher, I'll refresh you with the basics. If you don't need it, then nobody raise your hands, and I'll just move right on. But if you raise a hand, I'll be sure to do that because that's really important in finding the correct analysis or determining the correct analysis. You really need to know what an independent and dependent variables are, and you need to know what different levels of measurement, nominal, ordinal, and scale are. So, and Melissa will update me that in a minute. Then we're going to go ahead and create an account in Intellectus. Melissa, everyone gets it for 1 day, 2 days? How
Yep,
long do folks get it
it'll
for?
be it'll be active through tomorrow. And we do have some hand raisers, so I would go through the basics.
Yeah. Got it. Thanks for that. And by the way, it's really, really inexpensive, to get it for a month if you're in the middle of analyses. And so, fear not, you don't have to get everything in the next day or two. Um, then I'll show you how to, one of the AI features that we've included in Intellectus is a data cleaning wizard. And I'll show you how to set up the data, but how that data cleaning wizard really works. And it really streamlines a lot of the tasks involved in doing quantitative data analysis. For those that have done quantitative data analysis, like myself and many, many, many others, about 95% of the whole job is data cleaning. So to get some support around that is helpful. And then we'll go into the conducting of some analyses. I'm not sure I'm going to get to all of those, but we'll we'll I'll demonstrate some of those things. If you want to share your project, Melissa can throw in my email address, and that's the Intellectus 360 account, and you feel free to after after you've created your account, if you want to share some of your data, that's fine, and we can work through some of that. Um, and then I'll show you how to download your results, and then we'll wrap it up with some questions and answers that you might have. Okay, so first things first, at a very basic level, it's important to know that quantitative data is assigned different levels of measurement. So there's basically three of them. One of them is nominal, and it's that Venn diagram icon. And you'll see those icons throughout to know what level, what variables are acceptable or not. And nominal is Latin for name only. And what this means is that we're just naming things. There's no ranking, there's no order, there's no nothing. There's just names. So Republican, Democrat, Independent, male, female, non-binary, whatever. Okay, you can have two levels, male, female. You could have 102 levels. So there's no order to these things. It's purely just naming things, and lots of variables like that. The next level of measurement is ordinal, and ordinal is ordered data. So with a horse race, first, second, third horse, the distinction here is that they are ordered, but they're not equal intervals. What I mean by that is the first horse comes in, the second horse comes in, a nose after that, and the third horse comes in, 2 lengths behind. So the distances between these ordered levels are not equal. You also have that with some of these Coca-Cola products. You have a small 8 ounce, You have a regular 12 ounce, and then you may have the super gulp at 32 ounces. If they're still selling them, and you, again, they're in order, but they're not equal. So the next one is really scale, and sometimes it's referred to as interval or ratio. And basically, you just think of the ruler as the icon, and that is that there's equal intervals between, hash mark 1 and hash mark 2, hash mark 2 and hash mark 3. Between year 1 and 2, it's the same number of days between years 2 and 3, and so forth. That's the basic levels. And it's really important to understand that because a lot of the tests only use certain levels of measurement. So in selecting the correct test, if you have an ordinal variable, you're not running a t-test. So that's necessary to know. This is just another iteration of what I just stated, nominal. There's no real distinction here between apples, but these are just names of fruits. Ordinal, in terms of activity level, sedentary to moderately active and moderately to very active. Sedentary, you may not exercise at all. Moderately, you might exercise once a day. Very active, you might exercise 10 times a day. So just to know that they're ordered. And scale, this is just on a temperature. The degrees between 10 and 20 is the same number of degrees between 20 and 30. 10 degrees, that is. Okay, so moving on from levels of measurement to independent, dependent, and covariates. Basically, the independent variable are the things that typically the researcher controls. That's to say, hey, gosh, I want to see if there's a difference in, the mile run by males and females, okay? And I'm selecting the, what I want to compare that time by, which is, sex in this case. So, I'm interested in run times by gender or sex. And that's called the independent variable, typically controlled by the experimenter. The dependent variable is something that depends upon those folks. So the actual time that they run a mile is dependent upon those males and females. So dependent variables or the outcome variables or the criterion variables. So there's several names for the same thing. But dependent variable is a very common way of phrasing this outcome variable. How many minutes did it take one to run the mile? The covariate are things you basically want to control for. So if I was looking at, and not a lot of tests actually use covariates because there's covariates variables that are potential covariates that you measured. There's going to be a whole lot that you do not measure. So the important thing to know here is that if you do measure the variable and you do want to control for that a covariate is something that you want to neutralize the effect of. For example, if in fact I was looking at run times by sex, male and female, but I noticed that in the male group, they tend to be older, and the female group, they tend to be younger. And I think, well, gosh, maybe they're running quicker, the females, not because of their gender, but because of their age. So I can use age in this example as a covariate. That is, I want to neutralize the effect of that. And the analyses will take that into account. And then give me the results of whether or not there are differences on runtime by sex. So in a nutshell, that's kind of the independent, dependent, and covariate. I'm a big fan. I'm sure my team is thoroughly annoyed. I love ChatGPT. You can put those in and say, what's the distinction between an independent, dependent, and covariate? What is the difference between a nominal, ordinal, and interval level variable? So you don't have to get stuck. So just ask those questions. All right, so now is our time to log in to Intellectus. So everyone should have well, Melissa, do you want to walk through this process of how folks are logging in?
Yep, everyone should have received an email with the login link. I'll also put it in the chat right now. You can just click that link. If you have an account, just log in. If you don't have an account, you can click to create one and then log in from there.
Okay, that's great. So and everyone can see the chat and use that link. So
Yep.
terrific.
And if you have questions, just put them in the Q&A and Ashley and I'll help you out.
Yeah. Okay, so while you are all logging in, I will just state again that that really a lot of individuals doing quantitative analysis struggle with selecting the test, navigating the tool, and interpreting that output. So if you're in one of those three or all three, fear not. The tool is there to help you navigate through those. So and okay, so let's just get into so if you have your own data set, you can follow along. If you want, I will share how to open up other data sets. So for those that do have data sets available, I would invite you to click on the upload data file in which you can upload a CSV, Excel, SPSS, or other file formats. You can also choose an example data set. Okay. All right. Or you can enter data manually with just the variable name and the data underneath and so forth. But I want to demonstrate the data cleaning wizard because, as I say, it takes a lot of time to get data to in sufficient shape to be able to use it for the analysis. So that's what I want to do. So I want to upload an Excel file, and this one is called the Rosenberg Self-Esteem Scale, and just go to Upload File. Okay. And then it's going to jump right into the data cleaning wizard. I should show you all what that what I've just uploaded. So, and this is a very typical data file. And in that typical data file, basically you have some, demographic variables. Okay. You have some perhaps pre and post test score. Okay. With some Likert type items. All right. And then we have an open-ended question. So very common. Okay. And if it comes from Qualtrics or SurveyMonkey, it may have several rows of headers. And okay. So just to share that's how data may look. Okay. So let me go ahead through the data cleaning wizard. And very simple. So the first thing is to get rid of the headers. So in Intellectus, we just really need the variable name, okay, and then the data underneath it. We don't need these additional the question name or the levels and things of that sort. So I just endorse those additional rows of headers, apply those changes. You can see it's deleted those and go to next. And for everyone, just don't worry about taking notes. This is being recorded. Everyone will get the video. So just, hopefully absorb what's happening here. So there's edit variable names. So this happened to be age. This happened to be sex. This is really important because sometimes the variable name is so long that it's going to look terrible in a table, okay? So you want to just really kind of concise names. These names are fine, but Q1 and Q2, I just want to make those more descriptive, which is what I did. I'm going to apply those changes and go to next. So here, we I can make this a little bigger. Here, I want sometimes, even in typical data collection survey formats or platforms, it can make mistakes and, here disagree has 3 E's and 2 E's, or male has got a small m and male's got a capital M. We mean the same darn thing, which is the male category. So here I can merge these and it shows you what it looks like before and then what it looks like after. So I want to merge those two types of disagrees, okay? And then apply changes. And this is for every one of the variables, it's going to do that. Where it finds or picks up that, we think you mean the same thing here, all right? Okay. So we'll merge those. And that's going to help you out down the road um, in lots of ways. When we're changing them into numbers and when we're creating composite scores, you're going to need just the accurate levels of measurement there. So I do have Likert type items in my data set. It happens to be a 5-point agreement scale. And just you can see that there's lots of different options there. Okay. Um, so, you should know what kind of Likert items you have. It may look like that to begin with. They may represent these kinds of numbers. And I want to, in fact, turn those levels into these numbers for these variables. And then apply changes. Okay, and there's nothing else to do there. If you had a different type of Likert item scale, you can do that. Okay, so but this one just had my knowledge 1 to knowledge 4 pre, knowledge 1 to knowledge 4 post, and all of them are on the same 5-point Likert scale. Okay, go to next. So now I want to create those subscales. So these are all my pre. That's all for my pre-test of knowledge. Now, sometimes there's a reversed coded item. Okay, so what that means is that if I was asking about knowledge and high numbers mean good knowledge, I might ask it in reverse. How little about this do you know? So some items are asked in the reverse, and you have to reverse code that or flip your 5 to 1 and 4 to 2. You have to flip those prior to creating that combining those numbers. So I'm going to identify what my items are, reverse coded items 1 to 5. I'm going to name my new variable called pretest. And you have an option of averaging or summing them. You should look at the scoring manual to see what they recommend. If you have a choice and nothing else, I like averaging them because I know what a 1 to 5 means. 5 means, highly endorsed or strongly agreed, and 1 means, strongly disagree. If you have something with 17 items and you're summing them, it's like, I have 7, goes from 17 to 17 times 5 is, 85. So, it's a little bit tougher to figure out what a 60 means. So, averaging is just a simple way to do it. Although some scales do want the sum, so they can have, a cutoff and say, hey, you know what, from 16 below, that's, whatever, not important or not diagnosed. 61 above, they are diagnosed or they are knowledgeable, things of that sort. So here I'm just creating the subscale name. I'm identifying how I want them computed, and I'm identifying the items, the reverse coding, and then the items there, and apply changes. I'm going to do the same thing for the post test. Okay, I'm going to average them. I'm going to identify my items I want to go in there. This one was reverse coded from 1 to 5. By the way, you notice that this new variable is created pretest, and then apply changes. Go to next. I have no more. This is just if you want to have a ID variable. If somehow a 22 got in there, I know to look for participant number 9. So okay. So once I do that, your data cleaning is in good force. So this is what we've done. We've changed those levels to numbers. I would just change this a little bit of more data management of make that ordinal instead of scale, because I've ordered groups of ages. And so 30 to 39, okay, and 40 to 49. And this is 50 to 59, and then 60 plus. Okay, and then I'm going to put that right in the same variable. I could make a new variable, but I'm going to put it in the same variable. And you can see that reflected here. So I have my demographics here. I have my original items here. I have this open-ended question, which we'll deal with in a moment. And then I have my subscales over here of pre-test and post-test. So one of the things that we did with AI and a little bit of statistical analysis is that we have this thing called text classification. And basically what's happening is we want to bucket those 20 open-ended responses into different categories. This is really helpful because often there's some open-ended questions, A, but the other thing is that now I get to interact with these. So it's come up with, one, two, three, four different kinds of buckets. So it's discerned what's in that open-ended write-up and put them into buckets. But now I can do lots of things. Hey, are there different males and females related to these leadership responses? Are there differences on some of these scores by these leadership responses? So it's really important that you get to interact with them more fluidly and quickly. All right. So the next thing I want to do is just show the plots. So there's 10 typical plots. We've sought to make these very user-friendly. So I'll just look at our profile plot. Here's our friendly icons, by the way. Okay. So that's showing us what kind of levels of measurement of the variables could go in there. So these are all of our scale variables. So I'm going to look at pre-test and post-test. Let's go ahead and look at it by sex. Or just for the fun of it, let's look at it by leadership nominal. Okay, and then hit submit. So you can see the pre-test and post-test based on their open-ended question. All right, so they all had higher scores or knowledge scores at pre, lower scores at post. In this particular data set, you can change labels to reflect the titles you want, export it in numerous ways, and so forth. So 10 different types of options there, very user-friendly to use. Let's just jump to some of the analyses. The analyses really run the gamut from descriptive statistics all the way through structural equation modeling, mediation moderation, and everything in between. So, the correlations, the t-tests, the ANOVAs, regressions, chi-squares and non-parametrics, and another kind of advanced analyses as well. So I'm going to just do a few simple things like descriptives. And typically descriptives are the demographics and then the research variables. So it's really important to run descriptives. Whether you need descriptives or not, you should run descriptives. And the reason is that if you notice that, for example, well, here's the nominal and ordinal variables. It's inside of an APA table. There's a quick write-up about what's inside that table. The most frequently observed category of age was 60 plus at 35%. But if something's amiss, you want to just glance at these things and say, does this make sense? Okay. Ditto for the scale variables. You can scroll over the APA table or into the APA table to say, well, the min and max is 2 to 5. If my scale is 1 to 5 and I have a max of 55, there's a problem there. So before you go spend time conducting the analyses and spend time editing the analyses, it's worthwhile to take 2 seconds to look at descriptives. All right, and then there's some write-up about that inside. Okie dokie. So let's just run some quick tests. Here's a paired sample t-test. For all of these different tests, I'm basically just selecting the test, putting in the variables of interest, okay, and then hitting calculate. Before I do that, I just want to state that in almost every dialog box, okay, there's a video tutorial. It's a 3-minute video tutorial, which kind of shows you how to do this. So then hit calculate. For each of these tests, one of the unique features of Intellectus that really separates it from all the other tools is the preloaded assumptions. You're no longer saying, what is the assumption, A, and B, where in this tool do I find it? We just load it right in there. So for the paired t-test, there's an assumption of normality. It not only identifies the test, it runs the test, and then interprets the test. That's pretty cool. So you get to have that right out front. Okay? The results are also unique from every other tool, is that the results are in plain English. Difficult to say, well, what does this mean? What does that P00.001 indicate? Well, what that means is that there were significant differences, okay? And you can see here that obviously that the post-test is lower than a pre-test. That happens to be a statistical difference, okay? That's the interpretation of it. That's an APA table. That's the effect size. And then a plot to go with that. So there's different use cases for research or for classes. If someone is in class, let me know. If you're teaching a class, maybe raise your hand and I'll take a minute to review that use case. Otherwise, I'm assuming that everyone is just kind of doing research. And then a bar plot with a scroll over. We also have the when a quantitative assumption is violated, as is this case here. We also enact the non-parametric equivalent test. That is, the Wilcoxon test is looking at pre-test, post-test without the assumptions. So it can automatically run that. Okay, you can see that there were significant differences there. Here's an interpretation of that. And then the appropriate box plot. All right, so in the beginning of this PowerPoint, I was saying, or in the middle of the PowerPoint, I was saying that there was really three problems. You know, what test do I run? How do I run it? And how do I interpret it? Well, I've just demonstrated 2 and 3, right? How do you run it? You pick the test, you put the variables in, hit calculate. And the interpretation is that plain English interpretation. So check, check. What we didn't do is how do you pick the test? Well, we have a decision tree for that. And this decision tree is helping to, once you know levels of measurement and IVDV covariate, okay, then I can use this to say, well, I want to predict an outcome that is scale. Well, I'm doing a linear regression, and then I can jump right into that regression, okay? So that's the decision tree. You can't make a mistake here. Let me say that differently. You can't break this thing. So practice with this and use this, and then you'll figure out what test you're seeking to conduct over here. The couple of other things I want to highlight real quick is that once you know your test, if you're writing a methodology or applying an IRB, well, you need to know 3 things. What test am I using? What are the assumptions of that test? And what is the sample size for that test? So I just demonstrated how to use the decision tree to figure out what test over here. Once I know I'm doing a linear regression, then I need to write what are the assumptions of that? Well, I just select the test, and this is a downloadable, editable description of those assumptions. I can put that into ChatGPT. Okay, it's referenced, and it's going to give you a good idea of what assumptions to examine. The other piece of it is the sample size. Well, gosh, how many people do I need? I know I need more than 2. I know I can't get 1,000 in 2. I can just go ahead and select the test for, let's just say, 1 predicted variable. And in short order, I can, know that for a medium effect size, different conversation effect sizes, for different effect sizes, I can download and edit that and say, hey, you know what, generally I would desire 55 cases or observations to run this test. Okay, so with that being said, I think I want to, so there's no data here. So let me just open up for questions, if there are any, and select the project. Let me just identify one other quick thing, and it's a different, I just want to highlight two other things. One is the video tutorial sitting here. There's a whole, 60 or 80 videos showing you how to. Let's just do that. How do I upload data, or how do I get started, or how do I conduct a t-test? That's one thing. The other thing is that there's consulting sessions. So not to be overly, well, let me just stay where it is. Just to know, we've sought to make the tool easy as pie. If you still get stuck, you can sign up for a session, okay? To have a competent statistician for 45 minutes, it's a pretty good value. Very good value. So, okay, so with that being said, okay, so one hand raised. So should I take that question, Melissa, or is that indicating that
Alice put a question in here, so if you just go to the Q&A, you can start working through those, and then we can unmute if necessary.
Okay, so let me go to the Q&A. Thank you. Q&A. Got it. Okay, so do you typically use the averages when you're using a t-test to look at a scale variable over time? It could be a sum. It could be a sum. I think you mean of the subscale. You could be a sum or an average. So the scoring of your instrument should be dictated by the instrument maker. So they'll tell you, hey, we're going to sum these items, or we're going to average these items. I was just using the example that it's easier for my brain to interpret an average, and because I know what 1 to 5 means. 1, strongly disagree. 5, strongly agree. I have some sense of that. So, okay. Can you show an example of an ANCOVA? Be happy to. So let me get back to my other data set here. That's what I was using. You can see it's very fluid here. Okay. So here is my data. And so for an ANCOVA, let's assume that we want to look at, differences on, so let's just go to analyses, okay? And let's just go to ANOVA, and then just click on ANCOVA. You notice that helpful little scroll over that's kind of hopefully validating what you want to be doing here. So, one common thing would be, hey, you know what? I want to see if there's differences on post-test by, let's just say by sex, but I want to control for if people started out with higher scores. So I may want to control for the pre-test. Okay. So it's an example of an ANCOVA. Hit calculate. Just like with all of these other tests, the assumptions are going to be built in, okay, which is normality in this case. We have helpful scroll overs to help discern whether that looks more normal or not. Home skedasticity, helpful scroll overs, outlier analysis, all without asking. Another homogeneity of regression slope, see if that assumption was met or not. Whether covariate IVD independence was met, that. And then here are the results. The model was not statistically significant. Okay, so there was no differences on the value, indicating that differences among the values of sex were not significant. So no differences on post-test by sex. Okay, and here are the ANOVA table in an APA 7 edition. If there were differences, we would be able to say, oh, God, well, you can see the means look very similar, right? So, but if they were different and you had more than male, female, or like political affiliation or something, that post hoc test would just come out. Can you show a path analysis? Does this do the same as the Hayes process model for mediation and moderation? So we do use Preacher and Hayes for the mediation moderation. So that's a sophisticated question. Oh, do this for the same. Okay, so you want both of them. Okay, so Alice, good questions here. Melissa, we want to find out more about Alice. All right, so mediation moderation, simple here. So just select the test you want to go, I want to go back for a second. So just to show you that there's several different models happening here, which it's very challenging to another platform, SPSS or other platforms, to really import all that syntax and then run that and look for the assumptions. It's a mess. Here you can just select the darn test, put in your DV, put in your IV, okay, and then select your potential mediator. Just select one at random and hit calculate. So here again, assumptions, assumptions, assumptions. That's not good, by the way. If it's greater than 5, it might be a problem. Assumptions. Be careful when you look at the outlier. There's a tendency to say, hey, gosh, that's outside of these other scores, and to delete that person. One, that person might be real or is real. The other issue is that if you delete this, you may wind up with whack-a-mole, which is you delete that, now that one becomes an outlier. So be careful about how to do that. And then here are the results. Mediation was conducted, okay. And you can see the ANOVA tables, or regression tables rather. Nothing was significant here in terms of pre-test and K1 on the post-test. Here, the results of regression on K1. So it looks like K1 did predict the post-test, if I'm reading that right. So then this is what the model looked like, right? So does pre-test, does K1 pre mediate the relationship between pre-test and post-test? Here indicates that pre-test did not predict post-test. However, but here we are. The pre-test on post-test through K1, that is through mediation, was significant. Okay, so it kind of gives you those results. And I think I'm going to hold off on running this whole. So that's a la Preacher and Hayes. I think Pat's going to take too long, but let me see if there's any other questions, and then if there's time, we'll get to that. And Alice, we're happy to talk thereafter as well. Other questions, so I want to make sure I give enough time for folks. There's other questions? While you're thinking about that, I also want to state that there are 55 lessons. These lessons can be, purchased individually. If you're a faculty member, these can be curated, that is, select the lessons that you want. We can put it behind your learning management system. And then it's competency-based where grades go to gradebooks. So just know that this would really substitute for a rental of a textbook. So just to know that. Other questions? There's a lot of folks on. Don't be shy.
Question via email.
Pardon me?
Question via email about example data sets. Can you show for faculty that want to use those where those are?
Yes. So it's under projects when we're getting data in. So this is the choose an example data set. And we've had them curated in certain buckets. So some of them is by the test. So if I was demonstrated in ANCOVA, I can select that data set. And it will share with you what to use as a DV, weight, and what to use as IVs, side and level, and what to use as a covariate. And create that project. And now I have that data set, okay? So that's one thing. By the way, when you use those example data sets, feel absolutely free to change these variable names. Hey, I'm in economics, I'm in sociology, I'm in psychology. So you can change these variable names to suit your needs. With that, I should say that there's also a nice way of communicating between students and faculty or among colleagues with the share feature. So the share feature moves that whole project to another individual or shares it where you can work in serial fashion with it. So that share feature just basically puts in recipients or your students' email addresses or whatever. Okay, and click share. And that whole project will go there. And that project entails the all of the data and all of the plots and all the analyses and the notes that are included in the analysis and the notes at the project level right here. So those 5 components get shared and it would show up here. They'd get notified with a bell and an email. So that's the sharing feature. Other questions, thoughts, comments?
And just a reminder in that email, if that you received prior to the webinar, if you shared your project, it was the Intellect of Statistics email, Jim. Just raise your hand and let us know, and we can work
You,
to get those opened up.
you think it's on the other data set, the other
That's the one in the instructions is
oh,
intellectofstatistics.com.
I've got it. So okay. I don't see any bells here, any
And I don't see
notification.
any hands
Okay, that's fine.
raised, so
No
maybe
problem.
no one shared their project this time.
That's fine. Let me just go back here.
Oh,
Let me just do something here. So selection.
we have one.
We'll get there. Um, Let me just get this on the board though. So ah, I just want to put this. So I wanted to. Oh, I don't. Okay. So my problem is I thought that we had contact information. Evidently, I don't. All right. So let me just. This is what I want to get on the board here. Animate. So I just wanted to put this up here that if you want additional trials, or if you want personalized demonstrations, or if you want the courses to review, or if you want pricing, that you can contact Melissa, Ashley, or myself. We're available via email. We're available via phone. If you want to look at the quantitative tool would be the intellectofstatistics.com website, which has lots of information about the tool and so forth. So I just want to at least put that out there and have that available for everyone. So we look forward to hearing from you. Okay.
All right.
Okay.
I don't see any shared
That's fine. No,
project.
no
Well,
problem.
hold on a second. A couple of people raised their hands. If you want to share your project with Dr. Lanny, if you can just show people how to do that really quickly,
Yes.
and I'll
So
put your email in the chat.
so the sharing is simply logging in and then at the projects tab, and then you have your projects here, and then simply just go to go to share, okay, go to share, and then put in my email or other people's emails, James at, okay, and then just click share. So that's it. So you're clicking the share button here. Okay, and then put it in that email address there, and then clicking share, and then that's it.
And then we have a couple questions in the Q&A too that you can while they're working on sharing.
All right. Can you show an example on how to clean data when using data sets from SPSS 29? So I think and Melissa, you should ask Marlon, but I'm pretty sure the data cleaning wizard is only working for the CSV and Excel, but not for SPSS. So I believe if you uploaded an SPSS file, then you're into the manual, just like the project. If you've opened up an SPSS file, I believe you have to manually clean that. But I don't have an SPSS data file at the moment to do that. So, but Melissa will get an answer for us. All right. What's the difference between a t-test and an f-test? So a t-test is typically referring to a test looking at continuous variables by some dichotomous nominal variable, just like I showed with the, looking at pre and post tests or looking at some score by sex, something of this sort. An f-test is similar to a t-test, um, but it can have the independent variable can have two or more levels, and typically it's three or more levels. So if you were looking at run times by independent Republican Democrat, could not do that with a t-test because t-test would only has two levels. So the f-test or the ANOVA or ANCOVA really is looking at those independent variables with more than two levels. Okay. Regulating motivation, cognition in the classroom, the role of self-schemes. Okay. Um, so Allison, I feel like I just got part of the picture. So, okay, so maybe this is your data set. We'll find out. Uh, I don't know. But Allison, we're happy to talk after just to kind of understand. It might be that you have somewhat of a research question here, but we'd have to kind of look at the data to kind of sort that through a bit. Okay. So let's see here. I think I just accepted this. Okay. So let me take that project over for a minute. Okay.
And if this is your project, please raise your hand and we'll unmute you.
Thank you. So this is a great example that you really want to use the data cleaning wizard here because all of these are likely to be, a subscale where I want to have a 0 and a 1, for example, perhaps, and then I'm going to want to add them. Hey, out of 7, how many did you get correct, or how many yeses did you say?
And Alice, is this your data set? You can unmute now.
Hi, Alice. Alice, you don't want me to start singing.
Oh, sorry.
All
I
right.
had to rejoin because I guess we're not joined. So thank you. Hi, Jeb. How are you? Yes, some
Hello.
are item response, and then there are different levels. Some are 5 scale,
Yeah.
5 items, and some are 7 item Likert. And then I got confused when taking it over because it asks you which ones are scales. Yeah, and yeah, it was a little confusing.
So you
Oh,
are
because I wanted them to be scales and not nominal because those are scale
right.
variables, right?
Right. So that data cleaning wizard, if you were here at the beginning, you want to do that. So you want to do something like this. Just download the data.
So, uh-huh.
Amended sample. So basically, you want to do something like this. So if you go to upload data, and it's a CSV. Um,
So
so
I,
you
I did
go ahead.
okay. I tried the data cleaning wizard. So it went through it automatically, and I said make it a scale item, and then I got confused. I guess I would have had to watch a little 3 minute video to know what it was talking about, but I was paying attention to you, so I guess I didn't clean it fully. Yeah, I
You
went
didn't
through
clean it at
this.
all. So you want, I think let me get out of here. No, so the data cleaning wizard, cancel.
Yes, I was at this page and I
Yeah,
tried
yeah.
to keep those as scale variables.
Well, yeah, you don't want to change those. So you have to use the data cleaning wizard, which is turning these levels into numbers. or you're going to be doing it manually, which is fine. You can do that. So you can, click on here. So the simple thing to do.
So this came down, this was SPSS. So SPSS should have them both as labels and as numbers.
Right, but that's fine. To turn these into numbers, okay? All right, the FSS, what you can do, or for any other set of variables like the FFITs and so forth, what you can simply do is just go to recode multiple, and you can go ahead and select the FSS, okay? All right, and select your new level of measurement, which is going to be scale. So recode multiple, select the items, and I would do it scale by scale, by the way. Select your,
So I have a little question about that. So that means the numbers, because in SPSS it's linked. You can show the numbers or you can show the labels. And so you're saying the labels are downloading and the numbers are not downloading.
correct.
Um, okay. And so you have to go back and recode it to the numbers.
Yeah,
Okay.
because yes.
It,
Yeah.
it
We,
pulls
you
in a
know,
flat file, so it's not going to pull in both pieces of those SPSS files.
Uh-huh. So
so
is there a way to manage the SPSS file so it just pulls in the numbers so I don't have to go through this again, or no?
no, because you're going to wind up saying, hey, wait a second, was zero male or was one female? Was zero
Okay.
female or zero one? So the problem with these other legacy tools is that typically there's a code book. Zero means this, one means that. Okay.
Right, right.
You have that. So, this thing clearly you're going to want to create a composite score here, probably. Okay.
Okay.
You clearly want numbers. So why would they have that? So the fact is you do have that, but let's just carry on with this process. So by the way, you can bang this out in 10 minutes. Okay. So it's not like we're taking you to, Australia and back. You're gonna recode multiple, select scale, select the items, hit continue, and make sure these are in order. Okay. All right. And then just change these numbers to, 1, 2. Can I do this? I don't want to mess you up here.
Yeah, you can go ahead. This doesn't go back to my own, right?
Yeah, it does. So that's what I'm saying. So let me,
No, go ahead and do it because it's not going to mess with it on my hard drive. This is uploaded
oh, it's
data
not. It's only going to mess with it on the program, on the project
yeah,
system.
on the
So
platform. Yeah.
yeah, recode multiple, click on them. Okay. Change it to scale, click the items, hit continue, and make sure these are in order. Okay. And this is probably, it could be a 0 to 4, but typically 1, 2, 3, 4, 5. You could put it in the same variable, hit submit. Now I have numbers in here. Voila. Now I can create a variable calculator. I can call this the FSS. FSS. Do you know if these were summed or averaged?
So I think I did Chromebax and might have recoded one or two. So I did the scale analysis first, and then it might have a recoded item there. So I don't know because I don't see the yeah,
Okay.
but you can see how it hangs together. So you'll see how it hangs together first,
Right.
or
Well,
no.
that's a good protocol. So yes. So before you create a subscale, you should look at the Cronbach alpha. But since we're at the variable calculator, let's do this. And then I'll address that Cronbach alpha business. Okay. So just for everyone else's sake, that if we're doing this thing manually, that we can change these variables into numbers, and then we can create let's just say, mean composite score of those 4 items. They calculate. So it's taking them, adding them, divided by 4, hitting submit,
Okay,
and
let me ask you a question here. So
then
in
we have a new
SPS,
variable.
okay, what?
Then we
Oh,
have a new variable. So
okay. in SPSS, if it's missing a data point and you use the mean function, like in the 4, it divides by 3. So in yours, if it's missing a data point, is it still going to divide by 4, or will it automatically adjust if there's less than 4 pieces of data there?
It is not going to adjust and say, this person's missing one of the 4, this person's missing the second of the 4. No.
Okay.
So what I would do is if in fact that item was missing, happens to be a 1, right? So no, it's going to delete that person because it's missing all items. Okay. So the thing to do would be to impute that missing data. So I would go to imputation and to FS1. Okay. So, and you can maybe make a new variable for that or put it in the same one, but you want to, okay, impute that missing variable there. So it imputed a 2 rather than a 1 that was there, but it's imputing it based on these the
average
observations there. Okay, well, it's the average plus or minus some standard deviation. Plus, we should have that as an FAQ. But it's based on that. Importantly, it is allowing it to create a composite score without dumping that observation. Okay.
Thank you.
Yep. You got a big data set here. What are you doing?
It was experimental and one of the process models with multiple sequential mediation.
Got it. Okay. So did you check into this?
I'm sorry, did I what?
I'm just trying to articulate my words here.
Okay.
Did you use any of these mediation
I
models?
used Model 81. A Model 81 in the Hayes book. So I don't think you have it there, but I could probably get out it with the path modeling analysis
Okay.
because maybe that path modeling would be able to show, because if you do the path and you're doing sequential mediation, right, it should run like that, correct? It's like
I'm not an expert at it.
Okay.
So I cannot answer that, in a way that I have confidence in. So I don't know.
Okay.
If you shoot an email, I will have somebody look at that email.
It's okay. For this one, I'm not gonna move over. I just want to get an idea of what this software can handle.
Are you faculty?
I am.
Okay. And what do you guys are using SPSS? How do you find this?
I'm sorry, say that again. What?
Your faculty, how do you find this compared to SPSS?
How
Or is it your first exposure to it?
How do I find this compared to SPSS? So I like that it writes up the information for you. Some of the stuff I would never write up, but I've been using SPS for 20 years now. So
we're all hesitant to say how long we've been into it. Okay, I'm 30 years into it at least. So, but go ahead.
Oh, okay. So
it
becomes very quick.
Go ahead. So now what? So you use it, so you're used to it, of course, 20 years.
Right.
Yeah. Are there things in here are there things in SPS aside from the syntax that some people like? Are there things that SPSS does that you would say, you know what, this would be really helpful here? Are there things off the cuff? Yeah. I'm going to be vulnerable in here.
So, I use the Hayes macro a lot. I use it for almost all my analysis. I know you have mediation and moderation. It's a basic one. And when I do mediation and moderation, I'm putting in multiple variables and I'm selecting out cases, to see, does this hold for men? Does this hold for women?
I
but
see.
I don't know if everybody's going to be using that kind of analysis. But when you're publishing papers, that kind of analysis is necessary. So, but I do
Yeah.
appreciate the write-up that I can't get from
Yeah.
SPSS that I have to struggle and look back at. Yeah,
And I'll, and what I can say, is that this tool is not a panacea for everything.
right, right.
There's lots of good things like Data Cleaning Wizard that can work. That
Yes.
Melissa, did we get clarification that SPSS opens up into the Data Cleaning Wizard or not?
Does.
It does. So that Data Cleaning Wizard could be helpful in getting, those labels, if they were just labels, into numbers and composite scores. But it doesn't do everything. But gosh, for if you're running one of these, 8 models, it could be much simpler. So now you make me want to go into that path model.
Sorry.
No, that's fine. Well, let me make sure I don't have any other questions going. Okay, so I'm cool.
Oh, you could go on
Well,
to someone
actually, no,
else's.
because we don't have a clean data set yet.
Yeah, you could go into someone else's data set. My data set's a little complicated. I just pulled out the last one I was working on.
Yeah.
You know, it
Um,
has multiple, yeah,
yeah.
scales.
Um, okay. So, and I'll just do it because no other questions going on here. Let me see here. Okay, just very, very quickly. Let me do this just for everyone else that's on there, because my guess is very few people are going to be looking for a path. If you don't mind, let me just extend her, Melissa, and then just watch that video tutorial.
Okay,
3 minutes.
thank you.
I'll show you how to do it under the Edema. And I think you'll find certainly the write-up a heck of a lot better than some raw output in any other format. But it's easy to do, and you'll see how we do that. So I'll just direct you to that
Okay,
video tutorial if that's okay.
thank you.
Yeah. All right. All right, so let's just get wrapped up here. If there are additional questions, feel free to email. Let me see here. Too many windows. Evidently, when you have 20 windows open. So, um, so if there are additional questions, feel free to email us. Certainly, again, if you want any of this other information, email us or call us, email us, and then we're happy to kind of extend your trial, talk about how to integrate it into class, and so forth. So, and with that, I think I will how the consult works. Okay, so just talk about the consult real quick. So someone just asked about the consultation. Basically, you'll share your project or projects. We can help combine data sets, and you have a statistician with a decade of experience helping to support you to conduct analyses and manage your data in that time frame. As Alice, fortunately or unfortunately highlighted, it's not everything for all folks, but there are, a tremendous amount of analyses that can be conducted. But somebody's going to have some two-stage blah 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 regression that we don't do. So there are other tools. I like to analogize it to cooking, which is you come into the kitchen, you use certain utensils for particular tasks, but this is not all the utensils for every single task. So, but with that being said, I will say thank you all for your attention, and feel free to reach out. We look forward to speaking with you, and thanks so much, and have a good rest of the week.